In this video, you guys are going to learn how to find the exact trig function values given another trig function. And you are going to be able to simplify trig expressions. And also you are going to be able to prove identities. Okay, so trig identity is an equation involving trig functions that is true for all values for which every expression in the equation is defined. The identities help to evaluate functions, simplify expressions, prove identities, and also solve equations. Okay, so here are the fundamental trig identities. Okay, so the quotient identities. So tangent theta is the same as sine theta over cosine. But cosine cannot be 0 because that makes it undefined. And then cotangent is the reciprocal of tangent. Therefore, it's cosine over sine. Okay, and then the reciprocal identities. Sine is 1 over cosecant. Cosine is 1 over secant. Tangent is 1 over cotangent. And then cosecant is 1 over sine. Secant is 1 over cosine. And then cotangent is 1 over tangent. And then the Pythagorean identities. So cosine squared plus sine squared can be replaced with 1. Tangent squared plus 1 comes out to secant squared. And then cotangent squared plus 1 is cosecant squared. So those are your Pythagorean identities. You are going to learn how to use these identities to simplify trig expressions and also to prove the identities. So here you have to find the exact value of tangent theta if cosecant theta is -2, and then theta is between 3 pi over 2 and then 2 pi. So according to this, okay, you are going to be able to use one of the Pythagorean identities to find out what tangent theta is, because one of the Pythagorean identity is cotangent square theta plus 1 equals to cosecant squared theta. Okay, so you can use this to come up with cotangent, and then from there you can find tangent because tangent is the reciprocal of cotangent. We're going to plug in, because we know what cosecant is, we can plug in -2 for cosecant, so it's going to look like this. Cotangent squared theta plus 1 is -2 square. And then cotangent squared theta plus 1 is 4. And then we solve for cotangent. So -1, -1. Okay, so here we have cotangent squared theta is 3. And then to get rid of the square, we would have to square root it. Okay, so if I square root cotangent square, I have to square root the 3. So this will give me just cotangent theta is square root of 3. And then next I have to determine if this is going to be a positive square root of 3 or a negative square root of 3. Okay, so I have to go back and look at theta. What quadrant is theta in? Okay, so this is in quadrant 4. And then quadrant 4, cotangent is negative. Okay, so then we go here. Then we make this a negative number. So cotangent theta is negative square root of 3. Okay, so since we're looking for tangent theta, okay, we're looking for the reciprocal of negative square root of 3. So this is over 1, right? So this is going to be -1 over square root of 3. And then you have to rationalize it. right? You take negative 1 square root of 3 times square root of 3 over square root of 3. So your answer is going to be negative square root of 3 all over 3. So the exact value for tangent is negative square root of 3 over 3. Now we're going to get into simplified trig expressions. To simplify a trig expression means to rewrite it as a numerical expression or in terms of a single trig function, if possible. Use the identities to help you simplify the expressions below. So here we are going to simplify tangent theta times cosine theta. Okay, so tangent theta times cosine theta. So simplifying this is to rewrite in terms of a single trig function. We know tangent is sine theta over cosine theta. Okay, and then cosine theta is just cosine theta. Nothing we can do to that. We'll make it over 1 because we're multiplying fractions here. So here when you multiply, you're going to be able to cross cancel cosine theta. So you're left with just sine theta. When you multiply these two trig functions, okay, you end up with sine theta. So here we have 2, take away 2 sine squared theta all over cosine theta. Okay, so we're going to simplify this. So we have to turn this into a single trig function using the identities to simplify it. Okay, so here we're going to have to use the Pythagorean identities. You see how you have cosine squared plus sine squared is 1. Okay, so you're going to use that, okay, to try to get rid of the sine square. Okay, you can pull a 2 out. So you got 2, right? So if you pull a 2 out, you have 1 minus sine square all over cosine theta. Okay, and then you can use one of these identities down here to simplify 1 minus sine square. Is there a way I can rewrite cosine square plus sine square is 1 to get it into 1 minus sine square? Yeah, I can do that. So if I minus sine square to both sides, I can get that 1 minus sine square on the other side. So cosine square is 1 minus sine square. And then you can replace 1 minus sine square with cosine square to get it down to single trig. All right, so here we're going to have 2 times, well, 1 minus sine square is cosine square all over cosine. And then you can reduce this by taking out the cosine. So I can take this cosine out with one of the cosine up top. So I'm left with just cosine, right? So my final answer here is going to be 2 cosine. So here we're going to simplify this one. So here we have secant theta. So we have secant theta times sine squared theta all over 1 plus secant theta. So here it looks like we're going to have to use the reciprocal identities and the Pythagorean identity. Okay, so we use the reciprocal identity for secant, Pythagorean identity for sine square. Okay, so first thing I'm going to do here is rewrite my secant. Okay, so secant is the same as 1 over cosine multiply, and then sine square theta here all over 1. Okay, so that's my numerator. My denominator is going to be 1 plus, and then secant is 1 over cosine. Okay, so you always want to break it down into sines and cosine. All right, so now when I multiply my top, I got sine square over cosine. Okay, and then I have to work out my denominator. So I'm adding here, and I need common denominator. So add here, I need this to be cosine over cosine to get that common denominator. So my answer is going to be cosine theta plus 1 all over cosine. So now I would want to change it to multiply. So I'm going to keep my numerator the same. So my numerator is sine square over cosine. Change it to multiply, and then flip the bottom. So cosine over cosine plus 1. So multiplying these two, I'm able to cross cancel the cosine. So then I have sine square up top all over cosine plus 1. Okay, now sine square is the same as, if you use the Pythagorean identity, sine square is the same as 1 minus cosine square, right? And then here cosine plus 1. And then 1 minus cosine square can be factor. Okay, it's a difference of two perfect square. Okay, so 1 minus cosine square can be factored into 1 plus cosine times 1 minus cosine. And that's all over cosine plus 1. Okay, and then you can cancel the cosine plus 1. So you can cancel those two, and you're left with just 1 minus cosine. Okay, so the final answer here, it's going to be 1 minus cosine. Okay, so what we did is we used the trig identities to simplify. Okay, so now we're going to get into proving identities. Proving an identity means to show that both sides of the equation are the same. Simplify one side using the basic trig identities of the equation until it is the same as the other side. Ideally, pick the side that is more complicated to work with. Okay, so let's take a look at an example here. So here we are going to prove that tangent theta all over secant theta is sine theta. Okay, so we're going to show that tangent theta divided by secant theta is the same as sine theta. Okay, so you're going to show that one side is the same as the other side, and you're going to pick the side that is more complicated to work with. So that means we're going to pick this side to work with. Okay, so we're going to simplify this. Okay, so first thing we're going to have to do here is rewrite tangent. So tangent is the same as sine theta over cosine theta. And then we're going to divide that by secant theta is the same as 1 over cosine theta. And then we're going to do keep change to multiply and flip. So sine theta over cosine theta times cosine theta over 1. And then from there we can cross out the cosine theta. So cross out the cosine theta, and you're left with sine theta over 1, which is the same as sine theta. See how it's the same on the right hand side of the equal sign? So you proved it to show that you have the same on both sides of the equal sign. Okay, let's take a look at the next one. So the next one, you got secant theta all over cosine theta minus tangent theta all over cotangent theta, and the other side is 1. Okay, so we're going to prove that this side right here, this is the more complicated side, that this side is 1. We're going to simplify the left-hand side using the identities. Okay, so what we want to do here is turn everything into sines and cosine. Okay, so secant is 1 over cosine, reciprocal identity, and then cosine, we leave it alone. And then over here, we have tangent. Well, that can be sine over cosine. And then cotangent can be cosine over sine. So I'm going to simplify each fraction. Okay, so I'm going to simplify this. And then I'm going to simplify this and then minus it. Okay, so 1 over cosine. So here we can go keep change to multiply and flip. So 1 over cosine times the reciprocal of cosine. So that's going to be 1 over cosine. So you end up having 1 over cosine square. And then minus. Now here you get sine over cosine times the reciprocal of cosine over sine. So that's also sine over cosine. Okay, so when you multiply, you get sine square over cosine square. Okay, so here is sine square all over cosine square. Okay, you can minus it because you have the same denominator. Okay, so when you minus the numerator, 1 minus sine square, and then you keep the common denominator, which is cosine square. All right, look, 1 minus sine square using the Pythagorean identity. It's going to be cosine square, right? And then cosine square down here. And then cosine square over cosine square is 1. We just proved that the left is the same as the right-hand side of the equal sign by simplifying the more complicated side, which is the left-hand side of the equal sign. Let's take a look at the next one. Next one is this one. Okay, so here we have secant square is cosecant square all over cosecant square minus 1. Okay, so we're going to prove this. Looks like we have to work the expression that is on the right hand side. Okay, so this is more complicated than this side. We're going to simplify the one on the right and show that this is going to come out to secant square. Okay, we're going to keep cosecant square for now, right? We're not going to change that to 1 over sine square yet. But here, this cosecant square minus 1, that's from the Pythagorean identity. Okay, so that's going to turn into cotangent square. This right here is cotangent square. Okay, if you go back and look at the Pythagorean identities. All right, so now we're just going to break these down into sines and cosine. Okay, so cosine square is going to be 1 over sine square. And then cotangent square is going to be cosine square all over sine square. Okay, so we're going to change it to multiply, flip. Okay, so we're going to keep the 1 over sine square. we're going to change it to multiply, and then we have to multiply by the reciprocal of this, which is sine square over cosine square. Okay, so multiplying, you're going to be able to cross cancel sine square. Okay, so you end up with 1 over cosine square. And what is 1 over cosine square? Well, 1 over cosine square is the same as secant square, using the reciprocal identity. And then if you look on the left-hand side of the equal sign, see right here, you have secant square. All right, so they're the same. Okay, let's take a look at one more. So this is going to be a little tough. So here you have cotangent minus tangent, okay, all over sine times cosine. Okay, so that's the left-hand side. Now the right-hand side is cosecant square minus secant square. Okay, so according to this, we are going to show that the left-hand side comes out to what's on the right-hand side. So we're going to work with the one on the left-hand side because it's more complicated. All right, so what we're going to do here is we're going to rewrite cotangent and tangent into sines and cosine. So cotangent is cosine over sine, minus tangent is sine over cosine, all over sine times cosine. Okay, so here we have to work out the numerator, right? Because we minus two fractions. So in order to minus, you need common denominator. So you need to multiply this by sine over sine. And you need to multiply this by cosine over cosine. Okay, so when we do that, we get cosine square. Take away sine square. All over sine times cosine. Common denominator. Sine times cosine. Okay, so now we have to do keep, change, flip. So we keep the numerator. So we're going to keep this. Okay, we're going to change it to multiply. And then we're going to multiply by the reciprocal of this. Okay, which is going to be 1 over sine cosine. So now we're just going to multiply. So we don't need this anymore. Okay, so when we multiply, we end up getting cosine square minus sine square up top. And then my denominator, we end up getting sine square times cosine square, right? This is not 1. Don't think this is going to be 1 because it's minus. The other one, the cosine square plus sine square, that is 1, but not this one. I'm going to have to think about this for a minute, how to go about finishing this up. Oh, okay, so here we're going to split them up so we can cancel some of them. Okay, so when splitting, so we can split up into two fractions here. So cosine square over sine square cosine square. Reduce it. And then here we have sine square over sine square cosine square. Okay, so here we're going to be able to cancel cosine square over cosine square. So you end up with 1 over sine square. You can cancel the sine square. So you're at 1 over cosine square. Oh, look at that. Now 1 over sine square is going to be cosecant square. And then 1 over cosine square is going to be secant square. Look here, it's the same. So that is how you prove identities. You're showing that one side equals the other side, and you always pick the complicated side to work with. Then once you're able to determine what side you're going to work with, from there just simplifying using the trig identities. It's important that you remember those trig identities instead of just go back and forth and try to look for it. Okay, so if you have those trig identities in your head, it makes it a lot easier to simplify.